Hello, madam. This is group 19, and my name is Heng Jun Wei. My ID is 190000390, and our course is EE.
Hello, madam. My name is Aubrey. My ID is 190000717, and I'm also from EE.
Hello, madam. My name is Eric Xiaxuwi. My ID is 190000760. I am from EE also.
So now we will start to present our project A. So this is the circuit for our project A. This is the design in multi-sim. So you may have a look on this. So now I will start to run it. So this is the value when our rheostat is equal to 10 kilo ohm. And now this is our graph for the circuit. So for now, I will first show our graph before transformer, which is TP1. This is the graph of our circuit before transformer. While for TP2, it represents the graph after transformer. And TP3 is the constant DC after bridge rectifier. And while TP4 is the constant DC after PS filter. And while for TP5, it is representing constant DC after voltage regulation. And TP6 is load voltage VL. Okay, now Obi will present about the theory.
I will explain our circuit. For the first part, we have input with AC voltage supplier with 240 volt with 1 kilohertz. For our first main part transformer, we are using the step down transformer with the ratio 10:1, 10 for primary, 1 for secondary. It will down the voltage from the 240 volt to the 24 volt. Still remain alternating current. For our second main part, is bridge rectifier. Okay, it's combination of 4 diode. The the bridge the bridge rectifier still provide the same polarity of the output for either polarity of input. Okay, for our third main part for AC convert to DC, this is our filter circuit combination of inductor capacitor. For the combination inductor of and capacitor, it will form a low pass filter circuit. It will pass the DC and the low frequency and cut the high frequency signal. Okay, for our fourth part, we are using the linear voltage regulator LM317T and one rheostat, two resistor, and one LED. The linear voltage regulator will changing the obstruction through a criticism. Circle means that it will change in the both burden and information. Okay, and keeping the output voltage constant. So the function of the rheostat is control the output voltage by adjust the resistance. Okay, the explanation is done.
Yeah, and I will change the value of the rheostat to get another graph. So now I will run it again to get another output. So this is the other output we get while we putting the rheostat value to 38.128 k ohm. So for the graph, it looks like this.
The output will show you the less than 15 volt.
So this is our schematic in Eagle for our project A, group 19. And it's same as in multi-sim, just this component is needed to find in Eagle for their name. This is the warning that we check when we're doing the circuit in the Eagle. So there's no errors in this except for the frame and this JP1, but it has no problem with it. Okay, so there are no errors and only warnings. And while for this is our breadboard in Eagle. So this is how it looks like. So this is our project A breadboard. What it looks like is this. So we just press this auto rotor, then we can get the wire is accordingly arranged in good. So I think that's all for our project A.
For project B. So basically, this is our project B. This is the circuit we use to detect the water level for given depth. We divide the water level into 5 levels, which is 1 cm to 5 cm, and we connect using the 5 volt direct current at the power supply. So we start from the white LED until the red LED. From the first 4 level, we use the light indicator. The light indicator. For the last circuit, we use the transistor. Use the transistor delay. Use the concept of flashing and beeping of the buzzer. The last circuit as a warning sign for that for the high water level. So for the theory behind this circuit is the transistor act as a switch, also act as an amplifier. So uh, I will focus on our last circuit, which is the flashing capacitor, the flashing LED and the buzzer. So I will talk about so initially the power supply is not connected because we didn't add any water, so the capacitor is untouched. So no current will flow through the circuit. So LED is off. But when we add the water and we reach the certain depth, the capacitor is charged until it's charged because the circuit is connected due to the water. So the voltage is high enough to switch on the transistor. So switch on the transistor, the current will flow through the LED, then LED will light up. But for the last circuit, the flashing capacitor, flashing LED because the uh, capacitor is charged high enough to switch on the transistor, so current start to go through the base terminal of the transistor, for completing the circuit of LED. LED will light out gradually. So after a few seconds, the LED will start to fade off. Because the transistor, the property of the transistor, and the property of the capacitor. The capacitor start to be charged up 30 seconds, so the LED will gradually fade out, will go out. So you will see it will light out and go out. And this cycle will start to repeat until we can see it flashing. So basically this is the concept of the.
So for the result, we have taken a few videos and we have taken a lot of picture. So this is our circuit looks like in real life.
And that's mine. That's my circuit.
Yeah, and let's go Eric's.